When dealing with multi-wire branch circuits, often abbreviated as MWBC, and shared neutrals, it is important to understand the implications of connecting all neutrals together under a single wire knot versus making separate neutral connections for each circuit. The core principle to grasp is that the neutral bus within the electrical panel is common to all circuits. This means that regardless of how you initially connect the neutrals within the junction boxes, they will ultimately be connected together at the neutral bus within the panel. Considering this, whether you choose to consolidate all neutrals under one wire knot at each junction box or maintain separate neutral connections, the electrical outcome remains the same. There is no electrical advantage to keeping the neutrals separated if they are sharing. However, there are practical considerations and best practices to keep in mind. While electrically equivalent, maintaining separate neutral connections can aid in troubleshooting and circuit identification. By keeping track of which conductors are on which bus, you facilitate easier identification and isolation of circuits during maintenance or fault finding. This practice ensures that you can quickly determine which circuits are associated with a particular neutral conductor, simplifying the process of tracing and resolving electrical issues. Furthermore, adhering to good wiring practices, such as maintaining organized and well-documented connections, enhances the overall safety and reliability of the electrical system. Balanced circuits are crucial for efficient and safe operation. When circuits are not balanced, it can lead to excessive current flow in the neutral conductor, potentially causing overheating and other hazards. By carefully managing the distribution of loads between the two buses, you can minimize neutral current and prevent these issues. Here's a more detailed explanation of the concepts involved. Firstly, understanding multi-wire branch circuits. MWBCs are wiring configurations where two or more ungrounded conductors share a common neutral conductor. This arrangement can save on materials and reduce conduit fill, but it requires careful planning and execution to ensure safety and compliance with electrical codes. Secondly, the neutral bus in the electrical panel serves as the central connection point for all neutral conductors in the electrical system. It is typically a conductive bar or terminal strip that is bonded to ground, providing a low impedance path for fault currents to return to the source. Thirdly, balanced circuits refer to the distribution of electrical loads evenly between the different phases or buses of the electrical system. In a balanced circuit, the current flow in the neutral conductor is minimized, as the currents from each phase tend to cancel each other out. Fourthly, unbalanced circuits occur when the electrical loads are not evenly distributed between the phases or buses. In an unbalanced circuit, the current flow in the neutral conductor can be significantly higher, potentially leading to overheating and other problems. Fifthly, good wiring practices encompass a range of techniques and procedures aimed at ensuring the safety, reliability, and longevity of electrical systems. These practices include proper wire sizing, secure connections, neat and organized wiring layouts, and thorough documentation. Sixthly, circuit identification is the process of tracing and identifying the specific circuits that are connected to various electrical devices and outlets. This is essential for troubleshooting, maintenance, and modifications to the electrical system. Seventhly, troubleshooting involves the systematic process of identifying and resolving electrical problems. This may involve using test equipment to measure voltage, current, and resistance, as well as visually inspecting wiring and connections for signs of damage or defects. Eighthly, maintenance refers to the regular inspection, testing, and upkeep of electrical systems to ensure their continued safe and reliable operation. This may include tightening connections, replacing worn or damaged components, and verifying proper grounding and bonding. Ninthly, electrical codes such as the National Electrical Code, often abbreviated as NEC, provide comprehensive guidelines for the safe installation and operation of electrical systems. Compliance with these codes is essential to prevent electrical hazards and ensure the safety of people and property. Tenthly, electrical safety is paramount in all aspects of electrical work. It involves taking precautions to protect oneself and others from electrical shock, arc flash, and other hazards. These precautions may include wearing appropriate personal protective equipment, using insulated tools, and following lockout tagout procedures. Now let's consider specific examples. Imagine a scenario where you have 8 circuits wired as multi-wire branch circuits, utilizing 3/4-inch EMT conduit. These circuits consist of 8 hot conductors and 4 shared neutral conductors. In this case, each neutral conductor serves 2 circuits originating from opposite phases or buses within the electrical panel. Connecting all 4 neutrals together under one large wire nut in each junction box will electrically function the same as making 4 separate neutral connections, one for each pair of circuits. However, consider the practical implications. If you need to troubleshoot a specific circuit, having separate neutral connections can make it easier to isolate and identify the circuit in question. By contrast, if all neutrals are combined, you would need to disconnect all the circuits to isolate a single neutral. To maintain good wiring practices, it is beneficial to label each conductor with its corresponding circuit number or function. This can be done using wire markers, labels, or color-coded tape. Proper labeling helps to ensure that circuits can be easily identified and traced, even if they are sharing a common neutral. Additionally, keeping a wiring diagram or schematic can be invaluable for future reference in troubleshooting. The diagram should show the location of all circuits, conductors, and connections, as well as any special features or considerations. When working with multi-wire branch circuits, it is essential to ensure that the loads are evenly distributed between the 2 buses. This helps to minimize the current flow in the neutral conductor and prevent overloading. To achieve balanced loading, consider the power consumption of each device or appliance connected to the circuit. Aim to distribute high-power loads, such as heaters or air conditioners, evenly between the 2 buses. Also, consider the length of the circuit runs. Longer circuit runs can result in voltage drop, which can affect the performance of electrical devices. To minimize voltage drop, use the appropriate wire size and keep circuit runs as short as possible. Another aspect to consider is the potential for harmonic currents in the neutral conductor. Harmonic currents are non-sinusoidal currents that can be generated by certain types of electrical loads, such as electronic devices and LED lighting. These currents can add up in the neutral conductor, potentially causing overheating and other problems. To mitigate the effects of harmonic currents, consider using a neutral conductor that is sized larger than the ungrounded conductors. Alternatively, you can use a harmonic filter to reduce the amount of harmonic current flowing in the neutral conductor. It's also crucial to adhere to all applicable electrical codes and regulations when working with multi-wire branch circuits. The National Electrical Code, or NIC, provides specific requirements for the installation and wiring of these circuits. Failure to comply with these requirements can result in electrical hazards and code violations. Moreover, always exercise caution and follow proper safety procedures when working with electricity. To energize the circuit before making any connections or modifications, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Remember, electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. In summary, while connecting all shared neutrals under one wire nut may not pose an immediate electrical problem due to the common neutral bus in the panel, it is generally better practice to maintain separate neutral connections. This facilitates easier troubleshooting, circuit identification, and load balancing. Always prioritize safety and adhere to good wiring practices to ensure the reliability and longevity of your electrical system. Remember to properly label conductors, keep a wiring diagram, balance loads, and comply with all applicable electrical codes. By following these guidelines, you can ensure that your multi-wire branch circuits are safe, efficient, and code compliant. Understanding how current flows in a multi-wire branch circuit is crucial. In a properly wired MWBC, the neutral conductor only carries the unbalanced current, which is the difference between the current flowing in each of the hot conductors. This is why it's essential to balance the loads across the phases. For instance, consider 2 120-volt circuits sharing a neutral. If one circuit is drawing 10 amps and the other is drawing 8 amps, the neutral conductor will only carry 2 amps, the difference between the two. However, if both circuits are drawing 10 amps, the neutral conductor will carry no current at all, as the currents cancel each other out. Now, imagine an incorrectly wired MWBC where the hot conductors are connected to the same phase. In this scenario, the neutral conductor would carry the sum of the currents in the hot conductors. If both circuits were drawing 10 amps, the neutral conductor would carry 20 amps. This can overload the neutral conductor, potentially causing it to overheat and create a fire hazard. Therefore, it's crucial to ensure that the hot conductors in an MWBC are connected to different phases. The NEC provides guidelines for identifying and marking conductors in MWBCs. These guidelines are designed to prevent accidental miswiring and ensure the safety of the electrical system. Typically, the hot conductors are identified by color coding, with black and red being common choices. The neutral conductor is always white or gray. In addition to color coding, it's also good practice to label the conductors with their corresponding circuit numbers. This can be done using wire markers or labels. Proper labeling makes it easier to identify and trace circuits, especially during troubleshooting or maintenance. Another important consideration is the size of the neutral conductor. The NEC specifies the minimum size of the neutral conductor based on the expected load. In most cases, the neutral conductor must be at least as large as the ungrounded conductors. However, in certain situations, such as when the circuit is expected to carry a significant amount of harmonic current, the neutral conductor may need to be larger. Furthermore, the type of wire used for the neutral conductor is also important. The NEC specifies the types of wire that are permitted for use in electrical systems. The wire must be rated for the voltage and current of the circuit, as well as the environmental conditions in which it will be installed. In addition to wiring and conductor considerations, it is essential to install overcurrent protection devices, such as circuit breakers or fuses, to protect the MWBC. These devices are designed to interrupt the circuit if the current exceeds a safe level. The overcurrent protection devices must be sized appropriately for the circuit and must be installed in a readily accessible location. Regular inspections and testing of MWBCs are essential to ensure their continued safety and reliability. These inspections should include a visual examination of the wiring and connections, as well as electrical tests to verify the integrity of the circuit. Any problems or defects should be corrected promptly to prevent potential hazards. In conclusion, working with multi-wire branch circuits requires a thorough understanding of electrical principles and code requirements. By following good wiring practices, balancing loads, and adhering to safety precautions, you can ensure that these circuits are safe, efficient, and reliable. Always consult with a qualified electrician if you have any questions or concerns about working with MWBCs. A professional electrician has the knowledge, skills, and experience to properly design, install, and maintain these circuits. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and follow safety procedures when working with electrical systems. Your safety and the safety of others depend on it. By taking the time to learn about multi-wire branch circuits and following best practices, you can ensure that your electrical system is safe, efficient, and reliable for years to come. Also, it should be noted that newer FSI and GFCI breakers are not compatible with shared neutrals. Please check your local and national codes for more information.